Sophia, there, I just saw your email, so I'll send it in for the class as well.
Okay. Sorry about that. I didn't see that I was seconds away from it cutting off. Also, I didn't know that you could just reuse the same meeting. Okay. So I guess we have a little bit more time. Okay, so if X, let's just review, I guess, that if X is not in A, but because X is in C, we would have that X is in C minus A, but not A. Okay. And so therefore X is in the union of C minus A and C minus B. Now if X is in A, we can't do the C minus A. Okay. We saw that if X is in A and X is in B, that's impossible since X is not in both. X is not in the intersection. Okay, so that tells us that X is not in B. In other words, what this of saying that A intersect B is contained in B. So since everything in A intersect B is contained, or sorry, everything that's anyways, okay. Okay, anyways, yeah. We have X is not in B, but now X is in C. So X is in C minus B. Well, if it's in C minus B, then it's in this union. Okay, and what have we shown? We've shown that C minus A intersect B is a subset of C minus A union C minus B. So now we just have to do the reverse. So now let X be in C minus A union C minus B. And now we have, our goal is to show that if it's in the union, it's in one or the other. And that is, we have to do like a case, proof by cases. So the first case, oh, that'll just, then X is in C, but also X is not in A. Then X is not in A intersect B. That's because A intersect B is contained in A. So X is in C minus A intersect B. And the other case is that X is in C minus B. Then X is in C, but not in it, not in B. And again, X is therefore not in A intersect B because A intersect B is contained in B. And that tells us that X is in C minus the intersection. And so we've reached this conclusion in both cases. So that conclusion is true whichever case. So we have shown now that C minus A union C minus B is a subset of C minus A intersect B. And we've shown both are subsets of each other. So now we have shown that the two sets are equal. Okay. That's the end of the proof. I didn't need to go through the proof to figure out if this were true or not. I just have to kind of, if I carefully draw a Venn diagram, that will tell me if this is true or not. Okay, so here's C, this is A, this is B. So this is A intersect B, and all the stuff that's in C, but not A intersect B, is this stuff. Okay. The stuff that's in, so it's the union of all the stuff that's in C but not A, union with all the stuff that's in C but not B. I would need like crayons or something to describe that, but okay. Oh, more people are missing. My bad. Let's see. I guess I have time for another question. Well, first of all, they want to clear up about that last example. And then if not, I'll do one last question. Okay. Let us prove that the symmetric difference is a set. Okay. Okay, so we're given A and B are sets. This is a set by axiom of pairing. And then A union B, which is just the union of the unordered pair. That is a set 2 by axiom of unions. Okay. Now, take all the things in A or B, A union B, such that X is in A or X is in B. But X is not in. I guess this is implied by the union, so we could just put X in the union such that X is not in the intersection. And that's a symmetric difference. This is a set. This is a set by axiom schema of comprehension. And that's it. I guess before I go, I want to explain again. I want to explain that in more detail. Let me do that. What does this mean? When I put the symbol union, the union symbol next to a set, it just means all the x's such that x is in S for some S in AB. Okay. This is the definition of this symbol. If I put a union next to a set, that means all the x's that are in members of this unordered pair. So this symbol means all the x's that are in either A or B, basically. Since S is in the unordered pair, if and only if X equals A or X equals B. So this means that the union of AB that's all the x's such that, oh, this means S equals A or S equals B. Okay. So if we rewrite this, this means all the x's that are in such that x is in S, where S is either equal to A or B. Long-winded way of writing that x is in A or x is in B. In other words, this is just what we would normally write the union like as, okay? And now notice the difference between that and this. When I did this union, this is a set with 3 elements. Okay. Now, if I take the union of that, that is all the x's such that x is in A or x is in B. In other words, it's just A union B union C. Hope you can read that. It looks okay. Okay, so it's just to remember sets have members, but sets can also be members of other sets. I see I missed someone in the chat. I'm sorry. I didn't see. So the question is, I didn't see how you got X is in A and X not in A. Oh, that's a good question. So this will be the probably last to that part. The 2 different cases here. Okay, so if we jump back one more page. At the very beginning, we started out, we're trying to show that everything in C minus A intersect B is on the right-hand side. So we start out that X is in C and X is not in the intersection. Okay. And I think this is what you were referring to in your question. Either X is in A or X is not in A. And that is just a statement like, logically, it just says P or not P. Put an or. Okay. And we're like, we can always assume that P or not P is true no matter what P is. Our proof splits up into 2 parts. One part assumes that X is an element of A, and the other part assumes that X is not an element of A. And those are the only 2 possibilities, so it's fine. Okay, so that's just like a logic trick or something. Okay. And it just so happens, yeah. Okay. Okay. Any other questions? Even if it's further back. Okay. Okay, if not, I guess we'll call it a day. Yeah. I will be uploading these videos to YouTube. So you can look out for that in case you missed part of the meeting. By Friday, I should be able to get the so that we can have meetings longer than 40 minutes. Okay. So yeah, that's it. Please try out the try to work out the questions on the assignment, and if you have any questions, send me an email. Okay, I guess that's it. So thanks everyone. I'll see you guys on Friday.